Welcome to Unit 2 in our Science and Technological Advances module, and in this one we're going to be looking at advances in science and technology. So to begin with, we're going to look at a short clip which overviews some of the recent advances in science and technology. It's starting to get a little dated because every year that goes by there's something new, but it gives you a good sort of sense of how fast the field's changing. I hope you found that interesting, and you see some of the things like the hover vehicles, things that just in the last year are actually really starting to become actually marketed. So really just quite fascinating, particularly some of those biological advances for people who are blind and have lost the use of their limbs. So it's quite incredible. So basic science fuels advances in technology, and technological innovations affect our lives in many ways every day. So because of science, we have complex devices like our cars, we have x-rays machines, computers, phones, but the technologies that science have inspired include more than just high-tech machines. So when we talk about technology and the difference between science and technology, technology tends to be defined as any sort of designed innovations, and it usually requires scientific information to aid in its design. So whether it's a flu vaccine, the technique and tools to perform open heart surgery, or a new system of crop rotation, it's all technology. It's where we've used scientific principles to inform the design of a particular innovation. So even simple things that you might take for granted are in fact science-based technologies. So the plastic that makes up a sandwich bag, the ink in your ballpoint pen, a tablet of ibuprofen, they're all technologies. So it's all here because of science. So yeah, usually we think of technology, we think of those big ticket items and those complex things like that are shown here with satellites and computers. But really, all of our everyday innovations we don't tend to think of as technologies, but they actually are. Importantly, though, we hear a lot about the positives, and that particular clip that we watched pretty much is all positive news. But though the impact of technology on our lives is often positive, in some cases the payoffs are less clear-cut. And it's important to remember that science builds knowledge about the world, but then people decide how that knowledge should be used. And we touched on this a bit in our first module on nature of science, and also in our third module on science and ethics. So how do we actually decide whether we can do what we want to do? So, for example, science helped us understand that much of an atom's mass is in its dense nucleus, which stores enormous amounts of energy that can be released by breaking up the nucleus. And this is a fundamental principle with nuclear energy use, where we can disrupt that and release that energy. The knowledge we can say is neutral, but how people have chosen to apply it may not be. So we know that we can use that well, and some people would actually argue whether nuclear power is a positive thing. It's known as a very clean energy source in that it doesn't produce a lot of byproducts that are environmentally dangerous, except we do have to store its byproducts, and that in itself is an issue. But things like medical imaging rely on nuclear technologies. And again, that could only be thought of as a useful thing. But then again, nuclear weapons. So where do we decide? We know now, science has given us this knowledge about the atom and what we can do with it, but who decides? And sometimes those payoffs can be negative. So an interesting area that stems from the early work in the atomic sciences is a field called nanotechnology. You may have heard of nanotechnology. So we know that every day more products and industries are turning to nanoscience to help them become more efficient or develop new features. But we're really only beginning to see the true potential of nanotechnology. So why is it important and how will it impact society? And what is it? You're probably thinking, I don't know, I might have heard of it, but I actually don't know what it is. So let's have a look. Now, this clip that I'm going to show you, and we're going to go through what nanotechnology is, it's a great clip. It's actually designed for primary students, upper primary, but I think it's such a good explanation. I would use this with junior secondary students as well because it makes it very understandable and you really see the scale. You can appreciate it because when we're talking about things that are very, very small or things that are very, very vast, like astronomy concepts, it's really important to have visuals so students can get some awareness. So let's have a look at this clip.
Hey, do you know what nano means? It means small, very small. It is 1,000,000 times smaller than the smallest measure on a ruler. If you want to get an idea of how small a nanometer really is, you'll need to take a piece of hair from your head. Go on, it won't hurt. Got it. Now take a good close look at that strand of hair. Not much to look at, is it? If we were to shrink you down, smaller than the smallest thing you can see with the naked eye, you will find that your piece of hair starts to look a lot more interesting. You are now about the size of a red blood cell. Your strand of hair is a massive tree compared to you. Even at this size, you're still about 1,000 times too big to be considered nano. To get you down to the nanoscale, we will have to shrink you to about 100 nanometers tall. Hey, where are all the lights? You are now smaller than the wavelength of visible light. You are practically invisible. But for the sake of demonstration, I think we should turn on some lights. At this size, the red blood cell is 1,000 times bigger than you are. It is like an enormous stadium. Welcome to the nanoscale. You could probably hold a common cold virus in your hands quite comfortably now. The rhinovirus is only about 30 nanometers across and is nearly impossible to see next to the red blood cell. A red blood cell is too big to be considered nano. However, it's made up of all kinds of nanomaterials. If you were to look close enough, you would see that the outer walls of the cell are stabilized by a flexible, mesh-like protein skeleton. The bars and connectors that make up this mesh are considered part of a nanomaterial. Without these reinforcing nanostructures, the cell would be much more fragile and not nearly as flexible. It wouldn't stand a chance in your body. Everything is made up of nanomaterials. Nanomaterials are an arrangement of molecules and atoms that, when combined, create stable building blocks that can be made into larger, more complex materials and structures. Which is pretty much everything, including this little piece of hair. I bet you didn't think there was so much going on in such a small amount of space.
I hope you enjoyed that clip. I think it's a great clip in that it's very understandable. It brings something that's quite complex down into everyday language, which is really the ultimate aim of what we want to do as teachers. We want to make information relatable to them. The minute it gets too high end and too complex, you're going to find that a bunch of them are going to tune out. So nanotechnology is the understanding and manipulation of matter between 1 and 100 nanometers, and this is known as the nanoscale. So in that, basically, if you think of a millimeter on a ruler, so that's the smallest little segregation you can see on a ruler, you'd have 1 million nanometers in a single millimeter. So that's how tiny it is. It's just tiny, tiny. Okay, so if you lined up 10 hydrogen atoms, the smallest atoms, they are the smallest atoms, this would measure at around 1 nanometer. So we're talking at the atomic sort of scale. So however, the term nanotechnology is in fact deceptive, as there isn't just one type of nanoscience. It's a whole field in itself. A broad range of scientific disciplines are now beginning to work on a small scale, which has led to fields as diverse as nanoengineering, nanomedicine, and nanomaterials. So really, a bunch of different disciplines are using these technologies in their own fields. The reason for the interest in nanotechnology is that what they've found is that nano-sized materials are often more useful than their large-scale equivalents. Nanomaterials are essentially smarter versions of themselves on a smaller scale. So what's so special about nanotechnology? So what are the advantages? So in your lifetime, you probably noticed the size of everyday objects shrinking. Mobile phones, although you'll probably notice they've started to increase in size, but that's because for functionality we do so much more on them. Video recorders, that's a good example, because I remember years ago when I've got my first video recorder when my first children were born. It was almost like one of those ones that you see on the TV that they hold on their shoulder, and now the latest one that I had it actually fit inside my palm. It was so small. So everything's getting smaller technologically. Science has now gone a step further and is taking materials and devices down to the nanoscale. But instead of just becoming smaller, at this size, scientists have seen new and interesting properties that arise in everyday materials. So it's not just that things are smaller or simplified, they're actually seeing different properties in materials at this scale. So you might have heard of something called nanosilver. And nanosilver can interact with and kill some viruses. We know that bulk silver can't do this anywhere near as well. And the reason is that the nanosilver is so small, it actually can get in at the same level as the virus. So your viruses are very small. So we need something that actually can interact on the same scale as the virus. So these unique properties make nanomaterials more efficient to work with and can save energy and money. So the screen of your digital camera, your clothes, and even your sunscreen may have all benefited from the help of nanotechnology. But like any technology, we have some possible limitations. So let's have a look at a range of benefits to society, and then we're going to look at potential problems. And because nanotechnology hasn't been around very long, we're still unsure of a lot of these perceived benefits. So it's thought that it can improve medicines and surgical techniques, particularly in the future. It can benefit society by developing better materials for stronger and more durable cars, houses, and furniture. It may help us get into space. So there's these ideas about having this space elevator that is made of strong carbon nanotubes, again in the very experimental stages. It could benefit us by reducing our impact on the planet with the help of more efficient alternative energy sources and water supplies. And it may benefit by helping us protect ourselves with strong clothing that could potentially deflect bullets, so with increased risk with terrorism and things like that. However, here's some of the potential problems. And these are things we don't know yet, because we haven't even had a generation yet that have been through society with nanotechnology. So it could create pollution we don't know how to clean up. Scientists aren't yet sure how we can remove nanoparticles from the environment because they're so very small. How do we actually capture them to remove them? And what are they infiltrating in the meantime into our ecosystems, etc.? They could cause problems, health problems. So scientists aren't yet sure whether nanoparticles can enter our bloodstream via certain products. If they can, there could be side effects involved, and these could even involve changes to our DNA because the size of the nanoparticles are actually larger than the DNA. It could cause problems by building superior nanomedicines and nano-engineered foods that only the wealthy may be able to afford. So there could be issues there, okay, with the disparity between, well, we could find something that could be really beneficial, but does it mean only the wealthy have access to it? It could lead to ethical debates over future technologies, for example, the space elevator or the use of nanotechnology in geoengineering. So there's a lot of science and ethics involved here. You know, just because we can do something, should we do it? So here's your activity. Now you'll notice on Learning at Griffith there is a reading called Nanoscience and Nanotechnology for the middle years. I'd like you to read through that just to give you a little bit more information because we've only just touched on nanotechnology. Then I want you to just consider these two questions, and you can consider both or just one in your response. Do you feel confident integrating nanoscience in your science classes? So would you feel confident to talk about this topic? And then the second one is, why should students learn about nanoscience? What would the reason be? What are the advantages of them knowing about these kinds of technologies? So if you could share your views about that on the discussion board. And then we're going to move on to our final unit in this module, which looks at collaboration and careers in science.